All right, let's factor out the greatest common factor on these. And we're going to start by looking at our first term, negative 35x to the power 4y to the power 5. And what I've noticed first is that it starts out as a negative. So I'd probably put a negative 1 as one of my factors right there. Now remember, a factor is a number being multiplied by another number, which would also be a factor. So I'm going to split up 35. Again, I don't really care about the negative. I'm just looking for two numbers that multiply together to give me 35. And the two that I would use would be 5 and 7. Both of those are prime, so we're going to circle those, which means negative 35 would be negative 1 times 5 times 7. Now, we're going to do, with the x's and y's there, we're just going to expand them instead of showing them in simplified exponential form. So exponential form is simplified repeated multiplication. So instead of showing that as x to the power of 4, I'm going to show it as x times x times x times x. And also the y is going to be 1, 2, 3, 4, 5 y's all multiplied together. And that gives me the factored form of the first term. Now we're going to look at the second term, negative 15x to the power of 3, y to the power of 6. And let's go ahead and just see what we get out of that. First, once again, I notice that it is also a negative. So I'm going to show that with a negative 1. The 15 splits up into a 3 and 5 factors. And those are both prime, which means that we can't factor that anymore unless we were to use 1s. Then we have 3 x's all being multiplied together. And then finally, we have 6 y's all being multiplied together. There's our first 5, and then a sixth one. And that factors out the first, the second term. Now we will factor out our third term. And once again, well, I do need a little bit of space there, but the 5 being negative means that I would look at that as a negative 1. So it's again a negative 1. And 5 is prime, so we're just going to multiply that by 5. No need to find a factor tree there. Now we're going to multiply that by 2 x's, and then we're going to multiply that by 3 y's, like this. And remember, the idea here is we're looking for the greatest common factor. And for each of the terms, each of these values is a factor. For example, negative 15x to the power of 3, y to the power of 6. It appears to have 12 different factors that we're showing right there. In order to find the greatest common factor, it has to be common for all 3 of the terms. And we'll have to remember that because that is what we're looking for, is common factors. But again, it has to be for all 3 terms. So we're going to start here. Again, I'm just going to notice right off the bat that I have a negative 1 for all 3 of the terms. So I'm going to write this in as its own common factor. The next common factor I see is going to be this set of 3 5s, so we're going to multiply that. There's another common factor. Then after that we have 1, 2 x's that we're going to multiply. There's 1, 2 x's that are common for all 3 of the terms. And then finally we've got the y's. We've got 1 set of y's, 2 set of y's, 3 sets of y's, all which are common factors. Now this is our common factors. Remember, we're looking for the greatest common factor. And to find the greatest common factor, all we need to do is multiply these out. So again, negative 1 times 5 is going to be negative 5. X times x is x squared. And y times y is y to the power of 3. This would be our greatest common factor. Now, as much as we'd like to be done with this problem, we just aren't. And that's because it said, remember, factor out the greatest common factor. It does, however, take those factors out of the 3 original terms. So now what we need to do is enter in to this set of parentheses the remainder of those 3 terms. So remember, the greatest common factor comes out of these 3 terms originally that we had. So I pulled it out here. Since it's a factor, it has to be multiplied by the other 3 terms. So we just do with this with a set of parentheses like this. Now from the first set of or the first term right there, I can look and see I've got a 7, I've got 2 x's and 2 y's, which means that term will now be a 7. X times x is x squared, and y times y is y squared. For our next term, which is from the negative 15, x to the power of 3, y to the power of 6, I have a 3, I've got an x, and I've got 3 y's. So this is going to be a positive 3, an x, and we have 3 y's all multiplied together. Finally, we have the final term, but notice here there are no extra terms left from our final term, negative 5x squared y to the power of 3. And you can see here in green where I pulled that out as the greatest common factor. There is a remaining factor there, though. You just can't see it, and I'm going to show it now. It's a phantom 1. So that final term just ends up being a positive 1. From this should be completely factored from the greatest common factor. But if you really wanted to check, you could take this greatest common factor that we did factor out and start multiplying these into the other 3 terms that we have left over. And what you should end up with is the original expression. And if you were to do so, you would get that original expression. But that's all we have for this problem. Hopefully that helps you guys out. We'll see you.